Welcome to The Road to Zero, a future-proof podcast, as we explore the changing nature of our economy as we look for prosperity and opportunity in not only preserving but also improving our environment. Today on The Road to Zero, we have Gideon Grader, professor at Technion and co-founder at H2Pro. Welcome, Gideon. It's a pleasure to have you with us.
Hi, thank you very much for having me on. It's a pleasure to be here with you.
Tell us, how did you get into hydrogen? What drew you into that field?
Okay, it's a long story. As you said, I'm a professor at the Technion, and about 14 years ago, I was asked by management to lead the local energy program for the university. And we came up with a very comprehensive energy program that is called GTEP. It stands for Grand Technion Energy Program. And one of the areas within this program was defined a way back then in alternative fuels. And within that program, one of the areas was hydrogen technologies. In other words, we recognized already way back then that this is going to be an important area. And together with colleagues, we developed a major program in alternative in renewable energy. So this is, I think, by far the largest program in Israel. We raised roughly $50 million in philanthropic funding. And this funding went to create several central laboratories, and one of them had to do with hydrogen. So the work that eventually came out as a spin-off in the name of H2Pro came and it grew out of that work. And in fact, the technology that we're developing in H2Pro started about 8 years ago. So this is perhaps in 2013 we initiated it.
Impressive, the infrastructure you've developed there, and I can see why it's produced some results. And tell us a little bit more about
in H2Pro, the underlying technology came about when we decided to decouple the two steps in electrolysis. So whereas in standard electrolysis, which has been around for many years, well, for about 200 years, the hydrogen and oxygen are actually made simultaneously. Okay, you have two electrodes immersed into a container. There's an anode and the cathode. You apply a potential in between them, and you split water. And in order to do this in a commercial way, you must have a separator in between the two in order to prevent the gas mixing. And this is something that is problematic from the standpoint of the cost of the assembly of these electrodes. It makes it difficult in terms of sealing the two compartments. And then again, it adds a toll. You take a toll, energetic toll, electrical toll, on the overpotential that you need mainly on the anode. And we decided to decouple this process. In other words, to turn it into a two-step process, a swinging mode process, where in one stage you make hydrogen and in the other stage you make only oxygen. And this enabled us to operate the cell without any membranes. So it adds a measure of safety, shall we say, to this process. And because the oxygen generation is chemical and not electrochemical, we save about 20-25% of electrical energy in this process. I'm saying that with a sigh, okay? It's not that simple, because we had converted an intrinsic loss of electrical energy into a thermal management issue, a thermal management challenge. And so it doesn't come without a pain, right? Without a headache. You have to resolve the thermal management because the oxygen generation is done by heating the electrodes. In other words, the cell has to become hot, and then a kinetic process kicks in, and the oxygen is released, and the electrodes is regenerated. So in principle, you would say that, well, if you have to keep paying for that heating, then you haven't achieved very much. And that is true, except for the fact that we selected the reactions in a way that the regeneration step is exothermic. So it releases heat. And the main challenge for H2Pro is to design the electrodes in a way that there is enough active material there that it can release sufficient energy, sufficient heat to overcome the thermal swing. Okay, and this is what we're doing at H2Pro. In principle, we can do it. There is more than enough energy to recover that heat, to recover that heat balance. And yeah, you need to design the electrodes correctly, and you need to develop the material, the electrodes with sufficient capacity to enable that process. And this is what we're doing at H2Pro. But the upshot of it is that you can put together the electrodes without any membranes. And it's a process very similar to putting together battery electrodes, which is why we are very hopeful and very optimistic about a mass production of these kind of electrodes, just like you do battery electrodes. And their only seal is an external seal. It's just a cylindrical vessel which can maintain the pressure, the overall pressure. And the reason for that is that we would like to work at roughly 50 atmospheres, which is the highest pressure in any of the commercial electrolyzer or the alkaline electrolyzers available today. So in order to work at high enough pressure, you need to seal this container. But again, this is a very simple act, just a cylinder capable of holding the pressure that we want to work in.
So it sounds like more akin to an like you said, electrolyte type electrolyzer vice the proton exchange membrane. And from what I hear from the heat, once you get started up, it kind of feeds itself in the heat process. Is that the trick for the system?
Exactly. So the system that H2Pro is designing is made out of many, shall we say, cylinders. We call those reactors. So it's made out of many reactors, and each reactor, at some time it makes hydrogen, and another time it makes oxygen. So it swings in between these two steps. Okay, and the hydrogen step is actually endothermic. It takes place roughly at room temperature, maybe 30 degrees, maybe 40 degrees centigrade. And the oxygen step is roughly at 100 degrees centigrade, maybe 110 degrees centigrade. Okay, so each reactor swings in between these two steps. Okay, one time it makes oxygen and another time it makes hydrogen. Okay, so what I've said before is that when the electrodes are designed correctly and they have sufficient capacity, they have they release enough energy during the oxygen step that they recover the temperature that they need to be at. Okay, so on the whole, the process can be continuous without need to inject additional heat into the system. But in any event, the heat that is required is what we call its low quality heat. Okay, we're not talking about heating to hundreds and hundreds of degrees. It's on the order of a swing mode of roughly 60 to 70 degrees between the cold step and the hot step.
And then the efficiency. So for what I've been reading is your system is about, what is it, 95% efficient, the design that you have to
Yes.
create
Yes.
hydrogen?
So on the electrode level, we have shown that the efficiency is nearly 100%. And we published this work in Nature. This came out in about a year and a half ago in Nature. But that's only at the electrode level. Okay, of course, you have a whole system to run. And we believe that, yes, we could be at the 95% efficiency on the system level. And we will allow for about 5% losses. This is mainly heat losses. Okay, now mind you, typically electrolyzers report their efficiency in the roughly in the 70% range. That efficiency does not include the losses in the power supply. Okay, and this now depends on what kind of power supply you have. So what we believe that 95% that we claim that we will reach also does not include the inefficiencies of the power supply. And typically power supplies they lose a few percent. Okay, so some of them are perhaps in the 98 percentile, 97, 96 percentile. That's the type of efficiencies that the power supply demonstrate. So in the 95% that we claim, we do not include that percentage.
But yeah, you said the figure that's prominently used is that 65 to 70, so it's quite a jump. Quite a jump in performance, which is quite impressive.
What we started the H2Pro 2 years ago, okay, and when we started, we came out of the university making milligrams a day of hydrogen. Okay, the electrode size was 1 centimeter by 1 centimeter. This is what is reported in Nature Energy, in our paper. Okay, at H2Pro, we keep building larger and larger systems. Okay, so at this point, we're commissioning a 1 kilo a day system. Okay, we already came up about 3 orders of magnitude, and we have 2 more orders of magnitude to go. Okay, the first commercial system for H2Pro will be a 1 megawatt system. Okay, and that should come up in the plan is to complete that commission at the end of next year, the end of 2022. So as we speak, we're commissioning the 1 kilo a day system. In September, October, we will be commissioning the next system, which makes 10 kilos a day of hydrogen. This is already under construction as we speak. The next one will be a 100 kilo a day system. And then the final one will be a 500 kilo a day system, which is a 1 megawatt system. Actually, it will be able to produce closer to 600 kilos a day of hydrogen. And this will be the first commercial system for H2Pro.
Impressive. Yeah, so I see you're building up pretty fast. And is this system pretty? Would you say this technology is fairly scalable, modular? What's the
right?
How big do you see this can go?
Yes. So yeah, it is very scalable. The reason why it is scalable is what I alluded to before, that we have a multitude of reactors that each of them has a series of electrodes And the electrodes is the core technology that H2Pro is developing. And in order to scale up the electrodes, you have many options, right? You can make them longer. Okay, these are these electrodes we make ourselves. They're made by electrochemical deposition, so we make ever longer electrodes. And you can, of course, and those are rolled just like battery electrodes are, and then they're stacked one on top, one above each other. Okay, so the way to raise the capacity is, on one hand, to make the electrodes longer, so when you roll them, they take larger and larger diameter, and then to stack them more above each other. So and then, of course, once you have the reactors, then you line up more reactors in parallel. So this way, the reactors, the set of reactors that we are planning for the 1 megawatt system, and of course, this is the smallest size we're interested in. The size and is going to be considerably larger. It can be considerably larger than 1 megawatt. But that'll take simply the design of putting these reactors, some of them in parallel and some of them in series, and then, of course, developing the control to operate this machine in an efficient way. So yes, to answer your question in short, the system is very much scalable.
And it sounds like, I get you're still in the development stage, but once you get to that commercialization stage, how do you see this technology will compare in cost to existing technology? I think you've already alluded to that. There's obviously some elements that make it cheaper to some level.
Right. We believe that on large systems, this technology will be considerably lower capex than the competition, and the reason is that the heart of the technology, as you get to larger and larger scale, the heart of what you're spending money on is the electrodes. Okay, and the reactors, and to build those electrodes and reactors and to stack them together is much simpler than to put together a standard stack of an alkaline or a PEM electrolyzers. Okay, we simply don't have the need to seal each and every anode and cathode with a separator or a membrane in between. So if you look at the cost of the competition, a lot of their cost goes into the stack, putting together the stack. And for us, it's going to be considerably less expensive. And of course, as you have the stack, and then you have the balance of plant with the pumps and the separators and the analyzers. Well, all of these stay the same. They don't change very much when you increase the capacity. This is similar to what a PEM and an alkaline electrolyzer goes. So consequently, we think that at the end of the day, we will be able to offer a product that is, on the one hand, the capex is considerably lower than the competition, and of course, the OpEx, the operating costs, will also be considerably lower because of the lower electrical bill that you will get for every kilo of hydrogen that you produce, and because of the lower maintenance cost of having having no membranes.
So really here a very revolutionary design. And then have you seen any other big change in electrolyzer technology compared to this before?
First of all, I think that this market is very active, right? And the competition is trying their best efforts to reduce their cost as well. And I'm sure that their cost will come down. There's no question that as we march along, we will see the cost, and we're already seeing the cost of alkaline and PEM electrolyzers come down. Okay, they have come down considerably in the past few years, and they will continue to come down. So I think, though, that at the end of the day, yeah, our prices will also continue to come down. And so this is on the capex end. So I think that at the end of the day, we should be very competitive with the alternatives. And as we said, operating cost is lower. And even if, if you take a utopic world and the electrical energy is for free, yeah, as we know, electrical energy is coming down, right? I mean, the cheapest electricity today is solar, right? Is photovoltaic electricity. And some places in the world, it's coming down to, I think, 1.5 cents per kilowatt hour. Okay, in other places, even in Israel, it's some places it's 2.5 cents per kilowatt hour. So electricity is going to get cheaper and cheaper. But even if it is for free, right, then I could say that the equipment that we produce will be making more hydrogen per kilowatt. Okay, so just because you're that much more efficient than the competition.
Really got the benefit of that lower capital cost and the efficiency. Those are two
Right,
combined that really make this quite a good business
right. Now,
proposition.
having said that, we have to recognize that this market is going to be very, very large. Okay, it's a huge market. And there is room for everyone. Okay, I really believe that there is not going to be one technology that overtakes the whole market. Okay, so it's not the kind the winner takes it all. There is going to be needs for different technologies, different hydrogen technologies. There is really room for everyone. There are going to be different machines for different applications, I believe. For example, if it's a small user, they may be willing to pay more for the hydrogen, and they may be willing to pay more for the equipment. And some equipment is, for example, for us, we are not interested in small scale. Okay, we believe that for us, the market is at the large scale. And the larger it gets, the more efficient our technology will become. Okay, so for the small scale, let's call it sub megawatt, okay, we're not going to be there. But there may be other technologies that this is exactly the market for them. Okay, so I think that there is plenty of room here for different technologies. Maybe some technologies are better working with renewable energy. They can cope better with renewable energies. Others, perhaps they need very stable power. Okay, in order to work at steady state, kind of like a big power plant, right? I mean, that has to constantly produce electricity. So we are aiming in the large scale market. Okay, this is where we believe that our place is. As I mentioned before, for us, the hydrogen side, the electrochemical part, is at low temperature, so we have no problems working with a cold start. We have no problems of shutting down the system if there's anything intermittent, if there's a case of intermittent power, which is expected with renewable sources. So I think for us, we're going to be carving out that part of the market. And again, other producers may find it better to in a different segment of the market. But I really think that there is room for everyone.
And I think you're right too. And I think what we'll see too is there'll be so much demand, it might take a whole market to really just be able to keep up with the demand for
Right.
hydrogen. And so what I hear is you're looking at really a commercial demonstration in 2022. When do you see being able to fulfill larger orders and really being out in the industry? By what
Okay,
time?
thanks for the question. So we see ourselves in 2023 with several demonstration units in potential customers. And we would like to, we're planning to start sales in 2024 and 2025. So, in fact, we're already looking for the location of where to build our first plant. And we've identified a place, and this will start next year in 2022. We will start building this plant so that by the end of 2023, it's already able to produce commercially. And the demonstration units that, as we speak, we're building a fairly large, what we call an R&D production facility, which will be able to supply all the demo units in 2023, or I would say most of them. So some of the demo units in 2023 will come from the production plant towards the end of the year. But in the beginning, they will be produced in the facility that we're currently building.
And right now, anything that you're looking for, any partners or funding, what would benefit you at this moment on your journey?
That's a good question. We just completed a fundraising round about a month ago, so we're good for the coming year. The people who ran who orchestrated this round, who led the round, is Breakthrough Energy. I would say one of the top VCs that we came across. Very serious people. Okay, the due diligence that we had to undergo with them was by far the most severe that anyone has put us through. So joining them are a few strategic partners. Amongst them is Hyundai, the Korean company, the Korean car company, Hyundai, and another Japanese, very large Japanese firm called Sumitomo. And together with them is one of Israel's, the main Israeli oil refinery, which also has a stake in hydrogen. And beyond and there's also an American company, a very reputable and energy company called NFE, New Fortress Energy. And of course, joining them are VCs, smaller a bit than BEV, than Breakthrough. But they include iAngels and Our Crowd, and also the Hong Kong VC, the VC from Hong Kong called Horizon. So I think we're very much set for the coming year, and surely next year we're probably going to raise a significant amount of funding for the plans to build the first factory for the company. We are surely going to bring in some more strategic partners in the coming year. Yeah, this is definitely something on our to-do list.
It's great to see that you seem to be very well set up. So it sounds like for everybody else, they'll have to wait until 2024 when they can actually start making orders and building some plants with your technology.
Right. This is you can be sure that the companies where we're going to be putting the demonstration units are going to be selected based on the orders that they can place with us. Okay, and this is going to be part of the decision making for the company of where to put a demo unit. This is an important aspect of where you demonstrate. So we would like to demonstrate in several verticals and several end users. Not some of them will be from the chemical industry. Some of them, of course, will be from the refueling space. But yeah, we would like to select several verticals and make installations there of demo units. And of course, on the notion that they are potential serious buyers of the technology.
Sounds like you guys have a really solid plan, and thank you for really sharing this. And I really look forward to when this technology is out there, because you can see the cost curve of hydrogen just keep going down, and it's just wonderful to
That's
see.
right.
And I can see the contribution to that this technology.
That's right. That's right. It's very, very important to at the end of the day bring the cost of hydrogen down. If it is going to take us through and bring the utilization of the conventional type of fuels, if it'll help us to wean ourselves off the conventional type of fuels. It's the cost issue is at the heart of the whole game. You're right.
Thank you very much for sharing this with us, and I really look forward to hearing where this goes in the future.
Okay, thank you very much, and let's hope that not only us, also the competition makes a real breakthrough in this kind of a technology. Okay, thank you.
To hear more about our podcasts, showcase events, or the Futureproof Network, please visit us at www.futureproof-network.com.